Let's let the number of coins in our three piles be A, B, and C, where A is the pile with the smallest number of coins and C is the pile with the largest number of coins. And A plus B plus C is equal to 66. This leads us to think about using stars and bars as a way to divide up our 66 identical coins. So we're going to pick two dividers to be inserted in the 65 spaces between our 66 coins. And the number of ways to do that is 65 choose 2. Because our piles are ordered, one of our choices for our dividers, if it looks something like this choice is going to be the same as this other choice. But in fact, because our piles are ordered, these actually represent the same sequence. This is going to happen when we have three different sized piles, which is what we want for our problem. And these are going to be overcounted 3 factorial 6 times. We'll take care of that at the end of the problem when we divide by 6. We're going to use complementary counting because it's going to be pretty easy to figure out which are the invalid piles. Let's make a table. We'll start with our two smaller piles are equal to each other. Here are a couple of examples of invalid piles because A is equal to B, and we need to have A be strictly less than B. With A and B equal to 21 and C equals 24, we reach the last example of this case. Another invalid case is when all three piles are equal to each other. Our third case is when our two larger piles are equal to each other. Here are a couple of examples of this case, and this is our final example. Let's think about how these invalid piles are counted when we did our stars and bars. Our first invalid pile is overcounted 3 times. When we insert our stars and bars, one way we can do that is with one coin in pile A, a second coin in pile B, and the third pile has 64 coins. But the 64 coins could come in between our two dividers, or it could be to the left of both dividers. So we've overcounted our first example 3 times in our original counting. And similarly for the rest of these invalid piles in our first case. So I'm going to multiply this by 3 to keep it consistent with the stars and bars that we did above. We have 21 examples, each overcounted by 3. When we did our stars and bars and we selected dividers that divided the coins equally among the 3 piles, we did that once, so no need to correct. And similarly in our third case, when we inserted our stars and bars, we counted each of these cases 3 times. So I'm going to multiply these by 3 so that we can be consistent. And there are 10 examples in this third case. So now we're going to do our complementary counting, removing the invalid piles and accounting for their overcounting when we did the original stars and bars. Since the remaining piles all have different numbers of coins in them, and there are 3 factorial ways that we have overcounted them, or 6 times, we're going to divide by 6 to get the correct number of arrangements of piles. And doing the calculations, we get our answer 331.